Hello student, in previous class I discussed about different method for the calculation of equivalent mass. In the previous class I discussed about the hydrogen displacement method. According to the hydrogen displacement method, equivalent mass of metal is equal to weight of metal divided by volume of hydrogen in ml at STP into 11,200. This formula is used when the volume of hydrogen is expressed in ml. If the volume of hydrogen is expressed in liter, then the formula is modified and the new formula is equivalent mass of metal is equal to weight of metal divided by volume of hydrogen in liter at STP into 11.2. I have completed few problems regarding about this type of methods. Next, I explained about the metal displacement method. According to metal displacement method, W1 by W2 is equal to E1 by E2, where W1 and W2 are the weight of metal 1 and 2 respectively, and E1 and E2 are the equivalent mass of metal 1 and 2 respectively. I have also completed few problems to explain the metal displacement method. These are the problem. I have completed the problem number 1 and problem number 2. Next, in the description link, I have given a problem, and the problem is here 1.44 gram of KCl gave 2.87 gram of AgCl. If the equivalent mass of Ag and chlorine is 108 and 35.5 respectively, then what is the equivalent mass of potassium? For solving such type of problem, it is necessary to understand this node part. That is, the equivalent mass of KCl is equal to equivalent mass of potassium plus equivalent mass of chlorine. Similarly, I will give the other example. Suppose you want the equivalent mass of sodium chloride. Suppose you will think about the equivalent mass of sodium chloride. Then, as per this concept, I can write equivalent mass of sodium plus equivalent mass of, that is your chlorine. Similarly, you can think another example. Suppose I will think about the equivalent mass of KOH. Then what will be the formula? Equivalent mass of KOH is equal to equivalent mass of potassium plus equivalent mass of OH. You will take the summation of equivalent mass of the atoms present in a molecule which is equal to equivalent mass of that molecule. Now I will solve this problem. In this problem, the weight of KCl is given, the weight of AgCl is given, equivalent mass of Ag is your 108 and equivalent mass of chlorine is your 35.5. We know that as per the metal displacement method, here I can write W1 by W2 is equal to E1 by E2. This is the formula as per the metal displacement method. Suppose I will take W1 and E1 for KCl, then I will take W2 and E2 for AgCl. From the problem here I can find the given data. Weight of KCl, it is taken as W1 is equal to 1.44 gram. Weight of AgCl, which is taken as W2 and the value is 2.87 gram. Here the equivalent mass of silver is your 108 and equivalent mass of chlorine is your 35.5. According to the metal displacement formula, here I can write W1 by W2 is equal to E1 by E2. Now I will write weight of KCl instead of W1 and weight of AgCl instead of W2 and equivalent mass of KCl I can write E1 and I will write equivalent mass of AgCl instead of E2. Finally, I can write your weight of KCl divided by weight of AgCl is equal to equivalent mass of KCl divided by equivalent mass of AgCl. Again, apply this concept. Equivalent mass of KCl is equal to equivalent mass of K plus equivalent mass of Cl. Now I can describe equivalent mass of AgCl is equal to equivalent mass of Ag and equivalent mass of AgCl is equal to equivalent mass of Ag plus equivalent mass of chlorine. So I can modify this formula like this. Weight of the KCl is equal to weight of AgCl is equal to equivalent mass of K plus equivalent mass of Cl divided by equivalent mass of Ag plus equivalent mass of Cl. Here equivalent mass of Ag, that is your silver, is given 108. Equivalent mass of chlorine is given, that is your 35.5. Now put the equivalent weight in this formula, then I can write here. Also put the weight of KCl and weight of AgCl. Then I can write here 1.44 divided by 2.87 is equal to equivalent mass of K plus 35.5 divided by 108 plus 35.5. After simplification, here I can write by adding 108 plus 35.5, which is equal to 143.5. So here I can write 1.44 divided by 2.87 is equal to equivalent mass of K plus 35.5 divided by 143.5. Next, here I can solve like equivalent mass of potassium. Then here I can write down like this: equivalent mass of potassium plus 35.5 is equal to 1.44 into 143.5 divided by 2.87. Now I can find equivalent mass of potassium plus 35.5 is equal to 74.5. 74.5 is evaluated by solving this, that is your 1.44 into 143.5 divided by 2.87. After simplification, I will get the value 74.5. So finally here I can write equivalent mass of potassium plus 35.5 is equal to 74.5. Next, I can find equivalent mass of potassium is equal to 74.5 minus 30.5, 35.5. Next, I will find the equivalent mass of potassium. Equivalent mass of potassium is equal to 39. So, from the calculation, it is seen that equivalent mass of potassium is 39. Like such type of problem, you will solve different types of problem related to this concept. Sum of the equivalent mass of the atoms is equal to the equivalent mass of the molecules. In this class, I will discuss about another concept, very important concept. It is a very important concept. The application of this concept is very crucial, so it is highly necessary to understand clearly. That is mole concept. What is mole concept? The mole concept is applied in the future upcoming classes. So try to understand the mole concept. Before going to the mole concept, I will take few daily life example. Suppose I want to sell dozen. Suppose I will say you go to the market and bring 1 dozen of banana. What you will take? You will bring 1 dozen of banana. Then how many banana you will take? You must take 12 banana. You must take 12 banana. If I will bring 2 dozen of banana, then you must bring 2 into 12, that is your 24 banana. Similarly, you can think about 3 dozen, 4 dozen, half dozen, like that. 1 dozen means 12 banana. Here, dozen is a word which is used to express indicate 12 number of items. Similarly, if I want to say bring 1 dozen of pen, then you will bring 12 pen for me. Here, dozen is a word which clearly indicate about the 12 atoms. Like the dozen word, here also mole is a word which expressed for a particular number of items, that is your Avogadro's number of items. It also converted into weight. It also converted into volume. So here I will discuss first relation between mole and number. Suppose I want to say bring 1 mole of banana, then it is not possible, no, because banana is generally used dozen. It is not required to express the mole in banana. I am just giving for better understanding. Suppose I want to bring 1 mole of banana. Then how many number of banana you will bring? You must bring Avogadro's number of banana. Avogadro's number means 6.022 into 10 to the power 23. Or sometimes you can write 6.023 into 10 to the power 23. You use this value or that value. You use 6.022 in 10 to the power 23, or you use 6.023 in 10 to the power 23. Now comes to the mole concept and number. Suppose I want to bring 1 mole of banana, that means you must bring 6.022 into 10 to the power 23 banana. Similarly, if you will want to bring 2 mole of banana, then you must bring 2 into 6.022 into 10 to the power 23. Similarly, this concept now I will apply to the atom, molecule, ions, electron, like that. Suppose I want to bring 1 mole of sodium atom, then you must bring 6.022 in 10 to the power 23 sodium atom. Suppose I want to bring 2 mole of sodium atom, that means you must bring 2 into 6.022 into 10 to the power 23 sodium atom. Similarly, if I want to bring 3 mole of sodium atom, then accordingly you bring 3 into 6.022 into 10 to the power 23 sodium atom. Similarly, you will apply the mole in other cases. Suppose bring 1 mole of oxygen molecule, then you must bring 6.02 into 10 to the power 23 oxygen molecule. Suppose I want to bring 2 mole of oxygen molecule, then you must bring 2 into 6.022 into 10 to the power 23 oxygen molecule. Suppose bring 1 mole of H plus ion, then you must bring 6.022 into 10 to the power 23 H plus ion. Suppose bring 1 mole of electron, then you must bring 6.023 in 10 to the power 23 electrons. That means 1 mole is equal to 6.022 in 10 to the power 23 in number. So here I can define the mole in terms of number, like that. A mole is defined as, remember, again I will repeat, a mole is defined as the amount of substance which contain Avogadro's number, that is your 6.022 in 10 to the power 23 of particles. Mathematically, I have written like this: number of mole n is equal to number of particles, that is your taken as capital N, divided by Avogadro's number Na. This is the relationship between mole and number. Now I will move to the relationship between mole and mass. We know that for atom we generally use the gram atomic mass. For molecule, for atom we generally use gram atomic mass. For molecule we use gram molecular mass. For ion we generally use gram ionic mass. Let's take an example. Suppose bring 1 mole of suppose bring 1 mole of sodium atom. 1 mole of sodium atom. You bring 6.022 into 10 to the 23 sodium atom. It is in number. Suppose bring in weight. That means how much gram the weight of 6.022 into 10 to the 23 atom. That is equal to gram atomic mass of sodium. Gram atomic mass of sodium atom. We know that gram atomic mass of sodium atom is your 23 gram. That means 1 mole of sodium atom in number it is equal to 6.022 to 6.022 into 10 to the 23 sodium atom. In weight it is equal to 23 gram. Similarly, bring 2 mole of sodium atom, 2 mole of sodium atom, then you will bring in number 2 into 6.022 into 10 to the 23. In weight, what will be the weight? 2 into 23, that is your 46 gram. Suppose I want to bring 1 mole of 1 mole of Na plus ion. Then you must bring 6.022 into 10 to the 23 Na plus ion. But in weight, what amount you will bring? Remember an important point. If you will compare sodium atom and Na plus ion, only difference is the 1 electrons. The weight of the electron is very small, so it can be neglected. That means we can say that atomic mass of sodium is equal to we can say that gram atomic mass of sodium is equal to gram ionic mass of Na plus is equal to 23 gram. Here gram atomic mass is equal to the gram ionic mass because here the only difference is few electrons. The weight of the electron is very small, it can be neglected. So here we can say that gram atomic mass is equal to gram ionic mass. Suppose bring 1 mole of oxygen molecule. In numbers, obviously you will bring 6.022 into 10 to the power 23 oxygen molecule. If I want to bring the oxygen molecule in weight, then the weight must be equal to, that is your 32 gram, because 32 gram is the gram atomic mass, gram molecular mass of oxygen molecules. In case of molecule, mole is related to the gram molecular mass. In case of atom, the mole is related to gram atomic mass. In case of ion, the mole is related to gram ionic mass. Suppose bring 2 mole of oxygen atom, 2 mole of oxygen molecule, then you must bring 2 into that is your 32 gram, that is your 64 gram, because the molecular mass of oxygen is 16. Molecular mass of oxygen, atomic mass of oxygen is 16. Molecular mass of oxygen is 32. Your 2 mole is taken. So here I multiplied 2 into 32. That is your 64 gram. This is the relationship between mole and mass. For atom, I can formula like this: number of mole is equal to given mass divided by gram atomic mass. For ion, I can write number of moles is equal to given mass divided by gram ionic mass. For molecule is equal to given mass divided by gram. Take again few examples. Here 1 mole of sodium atom is taken. That means we can say that gram atomic mass of sodium. Gram atomic mass of sodium is 23 grams. So here I can write 1 mole of sodium atom is equal to 23 gram sodium atom. In number 0.022 in 10 to the 23 sodium atom. Similarly, you can think about 1 mole of oxygen molecule. That is your gram molecular of oxygen molecule. Here we can write 32 gram of oxygen molecule. In number, it is obviously 6.022 in 10 to the 23 oxygen. Here we can say indirectly weight of the 6.022 in 10 to the 23 oxygen molecule is must be equal to 32 gram of oxygen molecules. You can relate it to each other, mole to number, number to mole, mole to mass, mass to number. Like that you can relate it to each other. Similarly, 1 mole of carbon dioxide molecule must be equal to 44 gram of carbon dioxide. In number, it is equal to 6.022 into 23 carbon dioxide molecules. Like that, you can think 1 mole of Na plus ion, that is your 23 gram of Na plus ion. In number, it must be equal to 6.022 into 23 Na plus ion. Next, I move to the relationship between mole and volume. It is experimentally seen that the volume must be equal to 22.4 liter. If you bring 1 mole of any gas and the gas must be present at STP, that must be having the volume 22.4 liter. That means here I can say that 1 mole is also defined as the amount of gas or vapor that occupies 22.4 liter. That is your at STP. Mathematically, I can write number of mole N is equal to volume in ml of gas at STP divided by 22,400. If the volume is taken in ml, then we divide with the value 22,400. If the volume is given in liter, then here I can say that number of mole N is equal to volume in liter of gas at STP divided by 22.4. That means in volume, the mole must be equal at STP condition. You can also relate volume into mass and volume to into number. That means here we can relate it to each other. Mole to volume, number to mass, number to volume. As your choice, you converted parameters as per the main concept. Now take an example. 1 mole of oxygen gas. We need 1 mole of oxygen gas. It is a molecules. In numbers, we can think that it must be equal to 6.022 into 10 to the power 23 oxygen molecules. If I'll think about the weight, since it is a molecule, so it must be equal to the gram molecular mass. Gram molecular mass of oxygen is 32. That is 32 gram. In volume, the gas must be present at STP. Then here we can say that if I weighing the volume of oxygen gas of 1 mole, then the volume must be 22.4 liter at a STP condition. Similarly, you can take 2 mole of oxygen molecule, then what will be the volume? That is your 2 into 22.4, that is your 44.8 liter. Similarly, you take 1 mole of nitrogen gas, the volume must be 22.4 liter of nitrogen at STP and the weight must be 28 gram of nitrogen molecule and the number must be 6.023 into 10 to the 23 nitrogen molecules. This is the relationship between mole, volume, mole, mass, mole, number